So we also have an option to enhance the size of the objects by just clicking this plus sign. So you can make this network look bigger. So this is a simple local area network. This is a simple local area network, LAN. Okay, so this is a simple LAN, and we have connections available between these computers. So we need to assign IP addresses. But just before we assign IP addresses and enable communication between them, let's question ourselves that we assign an IP address to this computer as well as this computer and this computer. And let's suppose we are going to assign IP address like 192.168.1.1 for this computer. So let's assign. So you just have to click on this computer, a pop-up window will appear. In this, you have to choose the desktop tab. You can see the third tab here. Click on this desktop tab and new options appear here. And you have to click on this first object called IP configuration. And it is in this object that we are going to assign the IP address to the computer. So just click on this object and you get another window to assign the IP address. So you have two options. One is static IP address assignment and the other one is the DHCP option. So we will choose the static IP because we are going to configure the IP address manually to this computer, and the IP address is going to be 192.168.1.10, let us suppose. This is the IP address. And in the subnet mask field, you just click here, automatically the corresponding subnet mask would appear. So IP address and subnet mask are essential for the LAN communication. This default gateway is required when you want to communicate with a computer in another network. So for now, we just want to give the IP address and subnet mask, and we just have to press this X button here. We just have to press the X button here and it closes. Then we have to go to this fourth option called command prompt, or you can see the run here. Just click on this, we get the command prompt of this particular PC. We get a command prompt of this particular PC. So we want to check what the IP address was assigned to this computer with the command ipconfig, one single word, ipconfig, and you can see the IP address that was allocated to this computer, 192.168.1.10, and this is the default subnet mask. Similarly, we have to assign IP address to the second and third computers as well, and then want to check communication from computer 1 to computer 2. So from computer 1, we will know the IP address of computer 2 and we can communicate. But in reality, for computer 1 to actually communicate with computer 2, how does computer 1 know whether computer 2 or computer 3 has the IP address of 192.168.1.20? So your computer has an IP address, but how does it know this IP address is available to this particular computer? He will not know. So just having the IP address alone is not enough for communication in the network. You must have both IP address as well as MAC address to communicate with each other. So we have the next protocol to discuss called address resolution protocol. This address resolution protocol is very important for the actual data communication. So this is basically providing a matching between the MAC address and the corresponding IP address. So this computer has this IP address and that is mapped with this particular MAC address. So this is a very important protocol in the LAN communication. Without the ARP, the two computers in the LAN will not be able to communicate with each other. So this has two different types of messages. The ARP protocol uses two different types of messages called ARP broadcast message and ARP reply message. These are the two messages internal to this ARP protocol. So the ARP broadcast is sent as a broadcast to all the computers or devices in the network, in the LAN, and then only the device to which the IP address will match will process the request and send a reply message, whereas all other devices which have received this broadcast will discard this message. So The ARP reply is the message that comes from the corresponding PC back to the sender saying that this is my MAC address. So, according to this picture which we have just created in the network, computer A is given an IP address of 192.168.1.10 and computer 2 we have not yet assigned the IP address. At this point of time, if you verify the ARP table on this computer, there is a table called ARP table and we can verify using the command ARP space -A. When you look at, there are no entries at this point of time because our computer 1 did not send or receive any data to the second or third computer. So, there are no entries. So, the ARP table will be empty initially. Only when there is a communication, the ARP entries will be built. So, let us look at the ARP table information. What does an ARP table contain? The switch maintains a MAC address table. We have seen this in the previous session, how the switch builds the MAC address table. It will be empty by default and as and when the user send data, the entries will be filled in the MAC address table. The router will maintain the routing table. This we will see shortly in the next sessions. We will be watching the routing table output. Whereas these computers and servers, end devices, they maintain ARP table and we have just observed in one of the computers it was empty. But as and when you send and receive data, the ARP table will be built. So, the ARP table will contain IP address of the device and its corresponding MAC address, the IP address to which you communicate and its corresponding MAC address. And remember, this is available or applicable only for local area network communication. ARP protocol works only in the LAN, not on the WAN. It cannot cross the router. It is working within the network only, because router is a device which stops the broadcast and ARP is a protocol which works based on the broadcast. So, when a computer wants to know the MAC address of the neighbor computer, it will send a broadcast and it goes to all the devices in the network and the router will stop that broadcast. Router is a layer 3 device and layer 3 device has a capability to stop the broadcast. So, let us get back to find out the ARP table. So, you can have the ARP table on Windows operating system. We just have used this command ARP space -A is a command to verify the ARP table, and in Linux just the ARP command would do. So, we have an example of the ARP entries. You can see here, this is the command we have executed and this is the entries that we have at this point of time. But when we checked on the local computer here, there were no ARP entries because they were not learnt at all. And this information learnt is not permanent. There is a certain time interval after which these entries will be flushed away. And again, next time when you check the communication, the ARP table will be built. And the reason why I have not assigned the IP address to the second computer was so that we can check the communication and then the ARP table will be built. So, now to verify this ARP, we are going to assign the IP address to the second computer and then check communication from computer 1 to computer 2 and then verify the ARP table. So, let us assign the IP address to the second computer. Go to desktop, go to IP configuration and then assign the IP address 192.168.1.20. We have assigned 192.168.1.10 for the first computer, and for the second computer we have assigned the IP address of 192.168.1.20. So, we can verify the local computer's IP address with the command IP config, and we can see the IP address being assigned to this computer. And then also on the first computer we have assigned the IP address and we have also seen the ARP table. But now I want to ping from the local computer 1 to the computer 2 with this corresponding IP address. The local PC IP address is 192.168.1.10. The second computer IP address is 192.168.1.20. So, when I generate the request from the local PC, you can see that there is communication. There is a reply for the ping command. We have got the reply for the ping command. And now, if we verify the ARP table, previously when we checked the output, the ARP table did not have any information. But now we have established data communication, and let us verify the output of the Arp table with the command arp space -a. So you can verify now the IP address of the destination computer and its corresponding MAC address. So this table was empty earlier, but now we are able to get information. In a similar way, I am now going to assign the IP address to the third computer. Observe here, click on the computer, go to desktop option, go to IP configuration option, and then assign the IP address 192.168.1.30. Remember, within a local area network, every computer should have a unique IP address. This has to be manually assigned by the administrator. So next we go to the command prompt wherein we verify the IP config of this computer 192.168.1.30. So now we go back to the first computer. And ping 192.168.1.30. So this is the communication from the first computer to the third computer, and it is communicating. So now when we verify the output of the Arp table, we have two entries. This is the first computer, we have the IP address of the second computer and its corresponding MAC address, and that's the third computer IP address, and it is the MAC address of the third computer. So Arp table contains the IP address of the device and its corresponding MAC address. Without knowing the MAC address of the computer, the PC cannot send or receive data. So this is the importance of the Arp table and its functionality. And it all happen in the background. We don't use Arp manually. We are using the ping application or command. Ping is a command used for troubleshooting. Suppose there is a problem in the network, how do we troubleshoot? We use ping as one of the important command or utility. So with this we get to know whether that destination computer is reachable or not. Suppose at the same time if I try to give another command called ping 192.168.1.40, let us suppose, but I have not assigned this IP address to any computer. My computer does not know, so he's going to try, he's going to check, he's going to send the broadcast asking, hey, I am looking for the IP address called 192.168.1.40, but nobody responds. Suppose for example you are in the class and you call a person by name who is ABCD here in the classroom, nobody will raise a hand because that name does not belong to anybody. So similarly here, when we try to communicate with a computer IP which is not available, so this is the output we get: request timed out. When there is no computer available, or if the computer is available but it is turned off, if the computer is switched off, it will not be able to respond. So we get a message called request timed out. So in network communication, if there is communication between the source and the destination, we get a reply like this, which has information of, see, we are trying to communicate with the IP address, we get reply from the same IP address, and the number of bytes of data that was sent in the packet, and the amount of time the packet has taken to go and come back. This is the time interval taken to the packet to go and come back. And TTL stands for time to live. Though the name is time to live, is not related with a time object or time in sense. So TTL is actually hops. The maximum number of hops in TTL is 255. So from the source to the destination, every time the packet is crossing the network, the router will decrement the value by 1, and the final destination value cannot be less than 1. In case if the value goes less than 1, which is like happens to be 0, which means the destination is not reachable, and the computer or the router will display a message that time exceeded, cannot reach this particular destination. So ping helps us to know the communication between the source and destination. So in this session we have so far discussed about the subnet mask, the default subnet mask, how it is represented in the traditional notation, that is 255.0.0.0 for class A, 255.255.0.0 for class B, 255.255.255.0 for class C, and its corresponding slash notation, that is /8 for class A, /16 for class B, /24 for class C. And then we have discussed about the options of the allocation of the IP address and checking the communication. And now we have the topic called IPv6. The next discussion is about IPv6. IPv4 is very widely used, commonly used everywhere, but IPv6 was introduced in the year 2000, but the usage wise is very slow. So IPv6, we have already mentioned earlier session that it is there to overcome the limitations of IP version 4, because IP version 4 addresses are finished, they are no longer available. All the IPs which are available have been allocated to organizations, individuals, etc., ISPs, etc. So we have to use IPv6 now. The future is going to be about IPv6 for network communication. So this IPv6 address has 128 bits, and this is represented in hexadecimal notation, whereas IPv4 addresses are represented in decimal notation. IPv6 addresses are represented in hexadecimal notation. So we can look at here the IPv6 address. When converted into hexadecimal form, there will be 32 hexadecimal values, and this is the representation of an IPv6 address, full length IPv6 address, where here X represents one hexadecimal number, and there will be 8 quadrants: quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4, 5, 6, 7 and 8. So 8 quadrants, each of them are 4 hexadecimal values. When you multiply 8 into 4, you get 32 hexadecimal bits. And also there is a representation that one hexadecimal bit equals to 4 binary bits. One hexadecimal bit equals to 4 binary bits. And now we have 32 hexadecimal bits. So 32 hexadecimal into 4, we get 128 bits, which is the actual length of the IPv6 address. So an example of IPv6 address is represented here for your understanding, that is 2001:00:00:C15C:00:00:00:00:09C41300. So you can see how long or how lengthy this IP address is when compared with an IPv4 address. Traditionally, IPv4 addresses we have seen 10.0.0.1 or let's say 192.168.1.10. So shows small when compared with the IPv6 address. And since it's hexadecimal values, the values here, they are not case sensitive. These IPv6 addresses are not case sensitive. So there are rules available in IPv6. We can make this IPv6 address look smaller by using these rules. So when there are zeros in the beginning, we can substitute them with 0. We can omit them basically. The zeros can be omitted. This is rule number 1. So we had in the second quadrant 4 zeros. They have become one single zero. So that's one advantage of IPv6, reducing the size of the IPv6 address. If you have 4 consecutive zeros in one quadrant, we can substitute with one single zero. And if you have multiple quadrants successively with zeros, we can represent with just a double colon. So by applying these two rules on the previous page IPv6 address, you can see it has become so short by applying those rules. Okay. And another benefits of IPv6 is there are no classes, like in IPv4 we have class A, class B and class C. Here we do not have classes, and there is no broadcast in IPv6, has been removed. So these are the advantages of IPv6. Apart from the length of the IPv6 address, there are billions of IPv6 addresses which are not available in IPv4. And some of the IPv6 addresses you can see here: global unicast addresses. This is similar to public IP addresses of IPv4 used on internet. IPv6 public IP address starts from the IP address 2000. And if an IPv6 address starts from FC00, this is called as private IP address. It's called as private IP address. This is link local address, or also called as automatic IP address. This is automatically assigned by the computer. And loopback, this is loopback, similar to in IPv4 127 series IP address we have. This is IPv6 loopback, and this is also called as default. This is called as default IPv6 address. This is a loopback address similar to 127 series in IP version 4. I can show you quickly on the computer, on my local computer, a usage of IPv6 address, ping ::1, which is a loopback address. So you can see we get a reply from the operating system, which means the local computer has IPv6 support available. And when we check IP config on the local computer, we can see the IPv6 address support available or not from this. So we can see in the network properties, we go to the connections, and here, so you can see here from the properties IPv6. So you have IPv6 here, it's not available, so you can just enable it. So now when we come back after enabling IPv6 to the command prompt, you can see IPv6. You can see here the FE80, you can see here, this is IPv6 address. There is support available for the operating systems right from Windows XP, Service Pack 2 and 3 onwards. IPv6 is available. But operating systems like Windows 7, Windows 8, Windows 10, Windows Server operating system, they all come with default support of IPv6. So this is the discussion today, where we have learnt about the concept of a simple network, how to assign IP address in subnet mask, check the communication, and have the protocol ARP gather the information about the MAC address of the devices, and then check the actual communication as well as the IPv6 addresses. Okay, so in the next session we will be learning more about how the routers work, how to configure the routers, routing protocols, and check the communication with the practical sessions on the router. Okay, thank you for watching this session. Hello, welcome back to the Google IT course. Today we're going to discuss about networking services and connecting to internet session 1. So in the previous session we have learned about various protocols, various services that are used in the network layer, and we also looked at how the network communication takes place, and we discussed about how the ARP protocol works to actually enable the communication between the devices in the local area network. So today we're going to discuss about networking services. What are networking services? We use internet today for various applications, for various services. We use internet. We also use intranet for an organization. Let us say a bank. A bank wants to establish communication from one branch to another branch of the same bank. So then we need some applications of the bank so that we can complete the transaction. So similarly, you want to verify or check your email. So what we do, we make a request using the browser. So using the browser, we connect to the corresponding mail server. Let's say, for example, www.gmail.com. And then we get a web page. We provide the username and password, and then we get to see the emails that we have received, or you want to send the emails. So that's an application. We are using an application, and that in the background, with the help of the network, is able to send the email as well as receive the email. So basically, network services are nothing but applications. Like web browser is one of the applications. That's a client-side application. If the user wants to access the web page, we require a browser. But what is in the background? Who is providing the web pages to us? So there is a web server available in the internet, and it is with the help of the browser we are able to connect from the computer, from the PC, or from the mobile phone to the web server. So there is a client component, there is a network component, and then there is a server component. So these three facilities or facilitates us to communicate from the client to the server, whether it is for email or it is for web access or for any banking applications, or even for our day-to-day communication. We use the social media like WhatsApp or Facebook. So it's the same thing. We use an app on the phone, WhatsApp or Twitter or like Facebook, and then we send some message or a picture, and this goes from, using the help of a network, it goes to the server, Facebook server or WhatsApp server. From there it goes to the person whom you wish to send. So all these are related to each other, whether we call it as an application or we call it as a networking service. So let's quickly have a look at the applications that is available here. So basically, application layer is the topmost model of the TCP/IP model or TCP/IP layer. So we have in the previous sessions learned about the OSI model and the TCP/IP model, and the top application is on the top always. And with the help of this application layer, we are able to send and receive data. With the help of the application layer, we are able to send and receive the data for the various applications. Then some of the applications we use on the client side, on the user side, are web browser, FTP, Telnet, DNS, and many more. Whereas in the network layer also, we have discussed about certain protocols like routed protocols and routing protocols, and they are very limited in nature. Also in the data link layer, we have discussed about certain protocols. They are very limited in nature. But when it comes to the application layer, there are numerous applications or many different applications and protocols like HTTP, FTP, SMTP, DNS, DHCP, and many more. We also call these applications as network services, because all these network services work based on a client-server model. So some of the examples of the browsers, web browsers, we use some of them. Maybe a popular one is Google Chrome or maybe Internet Explorer. For some of you, you may be using Firefox. There are so many different web browser applications, and all these are basically the client application helping the user to communicate with the remote server. And similar to web application, we also have FTP, File Transfer Protocol. FTP stands for File Transfer Protocol. This protocol helps to send and receive large amounts of data or files from the source to the destination, and some of them are available here: FileZilla, Servview, Wing. We also have popular services. These are the clients, basically the clients. On the server side, we have applications like for web access or for web services. We have applications like IIS, Internet Information Server, for the Windows operating system, Windows Server operating system, Windows operating system, Microsoft Windows Server operating system has IIS. And we also have an open source called Apache. Apache Web Server provides applications to host web services. Suppose you want to access any web page, let's say zoomgroup.com or google.com. So these web pages have to be hosted on these servers, web server applications. And the client would be using a web browser to access these web pages. So these are all the various networking services, and then we're going to look at today how to establish data communication between these two networks. So this is one of the offices in, let's say, Amravati city, and this is another office in Hyderabad city. And we want the users of this network, these are all the users, and these are all the other users in another network. And you want to enable communication, like this user here should generate a request, and the request should go all the way via the router and reach the destination here. And similarly, when a user here in the local network of Hyderabad sends a request to a user in Amravati, the request should go all the way and reach the destination. So we have to enable the local area network communication from one office to a local area network in another office. So in the previous session, we had briefly set up just a local area network to establish the communication within the office or within the organization. But now for our network services to work, we are using internet, and let's suppose this is one of your office network and this is the remote network. How do we enable the data communication? How does the data communication establish from the source to the destination if they are in two different networks? So to understand this, we are going to look at the various functions that the router performs. Of course, we have discussed about the various functions of the router already, but we'll take a real example of a network in Amravati and another network in Hyderabad, and then we will see how the data moves from the local area network to the remote local area network. And we have set up a small network in the last session, the local area network, just to assign IP addresses, to check the communication between them, as well as to see how the ARP protocol works. But that example we're going to extend by having two different office networks in two different cities, and then establish the data communication using the various networking protocols or routing protocols as well as network services. So to build this network, we're going to use the same application like last time, that is Cisco Packet Tracer. So let's start by creating a network in this simulator, and then we will also see how to establish the data communication and verify the data communication. So in this session, we will also be configuring the Cisco router so that the data can be forwarded from one network to another network. So let's get to see this software. This is the software that we have used in the last session to set up a small local area network, and today we're going to establish a wide area network. So we are going to consider one of the routers here and then use it in the open space. We can increase the size of these objects. And then we need another router in another city. So let's say this is the two different routers. And then we have a local area network, so we require switches in each office. So we use a switch in both these office networks. And then we need few computers. So we go to the end devices here and then create some objects, end device objects. So we will have one server as well. So two PCs and one server just to represent a network. And similarly on the remote side as well, some computers and one server. So now we need to establish the physical connectivity between these. So we have, this is the connection wizard. So we can go to the connections, and like last time we can select how to connect these devices, connecting the router, switch and the PCs and the server. So one by one, using the same concept that we did last time, we can establish the physical connectivity. This is the server and the switch. We have the physical connectivity getting ready, and then we will check the communication between this local network and the remote local network. So we have the LAN ready now, and then we have to connect the switch to the router. Similarly on the remote side also, the switch to the router. But to establish the connection from one city to another city, we require wide area network, for which we have two options. We can choose to use the Ethernet interface, or we can choose to use the serial interface. But if you observe that in the picture, we had discussed about the connectivity using the serial interface or WAN interface. So we have multiple types of interfaces available to set up the network. So this particular module or serial port module is not available by default in the modular Cisco routers. So we need to add additionally. So the question is, how do we add the serial port module? So just click on the router once, and then we have the device. You should turn off the device first, and then add this module WIC2T, this particular module. We have to click on this module and drag it to the open space. We have to click and drag it to the open space or slot here, and then we should power on the router. So similarly, we have to minimize this and then go to the next router. On this router also we have to perform the same task. Just click on the power button and then select the WIC2T module, click on this and drag it to this slot here, and then we have the module set up. So we need to turn on this router back and then minimize this window. So we have a serial port module available on these two routers now, and we have to establish the connectivity. So we have to select this option called serial DCE cable. This is the cable that we have to select. Okay, so just click on the serial DCE cable and then click on this router once, and then a small pop-up window appears. So we should choose one of the two serial port on this router. So let's choose serial 0/0/0, the first serial port, and then we should take the other end to the other router and then click on this router, and we can see that there is serial ports also available on this router. So select one of them. We can connect any port of the router to any other port. So we have now a physical connection available between the local area network in one city and local area network in another city. So we can create labels just to represent that this belongs to so and so city. So let's give the city name as Amravati, and then we'll call this as, let's say, Hyderabad. So these are the two offices the company has, and we wish to communicate from this local area network to the remote local area network. So let's use our reference diagram here, and in this diagram you can see the IP addresses that have been mentioned here belongs to the router actually. This IP belongs to the local router. So we will have to assign IP address to these computers as well. So the IP addresses that we have to use in these two different networks, they must be different. Observe carefully. The IP address used in Amravati is 192.168.201.12345 for various network devices. Similarly, the IP address that we are using on the Hyderabad network is different from that we used in Amravati. That is 192.168.202.1 for the one router, and then similarly for other computers we'll have different unique IP addresses. So let's follow the same structure in our example as well. So for this computer, we have seen how to assign the IP addresses. Just click on the computer. So a pop-up window appears. Go to the desktop tab, and then we have IP configuration settings. Just click on the IP configuration settings. We could assign the IP address to this PC 192.168.201. Some number, let's say 10, and then the subnet mask. So last time also we just assigned the IP address and subnet mask. We did not use the default gateway. But remember, to establish communication from one local area network to a remote local area network with the help of the router requires us to define the default gateway. So the default gateway is an important parameter. We have discussed in the previous sessions as well, that the default gateway is always the router's IP address. At this point of time, the router is not yet configured. We will learn how to configure the IP address to the router in a short while. And here we have to specify the IP address of the router 192.168.201.1. This is going to be the router's IP address. So we have assigned the IP address to the router, and then we can verify that the IPs have been assigned by using the command ipconfig. So we have the IP address, the subnet mask, as well as the default gateway. All the three parameters required to communicate with the remote network are available. So similarly, I am going to add one IP address to this remote side computer, that is Hyderabad LAN computer IP address 192.168.202.10. So we have the IP addresses assigned, as well as the default gateway on this computer is supposed to be 192.168.202.1. This is the router IP address of Hyderabad. So we have assigned the basic parameters. All we need to do now is check whether there is communication possible. So we have the IP address of the PC and the subnet mask, as well as the default gateway. All the three parameters are present. So now we are going to generate a request or traffic to the remote computer that is in Amravati network. The IP address is 192.168.201.10. This IP belongs to the computer in Amravati network, and this IP belongs to the computer in the Hyderabad network. So you will find that there is no communication between the two computers. Though they are in two different networks, there is no communication. So to enable this communication between two different networks, we have to use the routers, and on these routers we have to enable the routing protocols. So that's our next step. So let's look at how to configure the router. So you can see these ports on the router, they are all in red color or orange color. You can see here, means they are not yet been enabled, whereas here on the computer and the server to the switch, the ports are representing green, means they are operational. Of course, we have used only one IP address on the first computers on both sides, but even though we don't assign the IP address, the physical connectivity is operational. So to configure the router, click on this object and a pop-up window appears. We need to choose the option called CLI. So this is the option we have to choose to configure the router. So just click here, and then we have the information that is available to configure the router. So normally on a new router, when you're configuring for the first time, you will see this message called system configuration dialog, and you will get a message that would you like to configure yes or no. Normally at this point of time we would choose yes, but technically it is recommended to use the option no. So the moment you choose no, you get a message called press return to get started, where that return is nothing but the enter key. So just press the enter key and you get some prompt. So this is called as Cisco routers operating system prompt, or also called IOS prompt. There are different modes in the router to configure. So we have the list of commands that are to be used mentioned in this presentation that we have just had a look. So to configure this, we have taken two different networks. One is called Amravati and other is called Hyderabad, two different networks. If we check the communication between the two networks and we verified that they were not able to communicate, already we have checked that just now, because the router does not know the path or the route how to reach the destination. So now what we have to do is, on the routers we have to configure the router and then enable the routing protocols. So when we enable the routing protocols on these routers, then the router would forward the request from the local network. From once we configure these two routers with the routing protocols, then the data from one network would be allowed to go to the remote network and vice versa. This would happen only when the routing is enabled on these respective routers. So from what we have learned so far, we are going to see this, the different types of routing protocols. The different types of routing protocols: one is static routing, two is dynamic routing, and the third is default routing. So to start with, we will look at how to configure static route and the commands that we have to enable on the router, so that the network in Amravati network can communicate with network in Hyderabad. So these are the various commands that we have represented here to use on the router. So first we are considering the Amravati router to be configured. So we have already got to the stage that it is asking for a question that would you like to configure yes or no. So choose the option called no. We have mentioned that here. So once we choose the no option, we have this keyword called router with a greater than symbol. So which is exactly available here, router with a greater than symbol. So we have this keyword here, router with a greater than symbol. Now we need to give this command called enable as mentioned there. Once you give the command enable, the prompt will change from greater than symbol to hash symbol. So we are changing the mode from user mode to the privilege mode. So we cannot do any configuration here in this privilege mode also. So we have to go to the next level called configure space terminal. This command will let us go from the hash prompts. There is a message that is available, that is enter the configuration commands one per line. So it's a message, just a message. So we now go to the next command, that is we are changing the name of the router, which is default is router name. We want to change that to Amravati, just a short form for Amravati. So we use the command called host name to change the name of the router. We use a command called host name followed by what name we wish to give. You can see that the prompt which was router earlier has got changed to Amravati. This is a short form. Okay, so we have changed the name. So next what we have to do is assign the IP address to the router's interfaces. I repeat, we have to assign the IP address to the router's interfaces. So the next command would be interface fast Ethernet space 0/0, and then we need to give the command IP address followed by the IP number that is allocated to this Amravati router, that is 192.168.201.1, followed by the class C subnet mask, which is default subnet mask. And since by default all the ports are in the shutdown state, we must give the command no shutdown. We must give the command called no shutdown. And the moment we use this command no shutdown, you will find a message that pops up on the screen saying that the fast Ethernet port, which was in the down state by default, has now come to the up state by giving this command no shutdown. And we must mandatorily give this command no shutdown as well as the IP address for every interface which we wish to send and receive data. So this is the command that we will be using. And then the next, we have to also enable the WAN interface or the serial interface. We already assigned the IP address and we are given the no shutdown command. So on this Amravati router, we have to configure the WAN port or the serial port. Remember, serial port is required to connect to the remote network or called as WAN. Maybe you may be connecting this to the internet as well. You may have to connect this interface to the internet as well. Maybe also we should consider another situation. In place of serial interface, you may be using the fast Ethernet interface 0/1 to connect to the ISP, because fast Ethernet 0/0 was connected to the local area network. We can have another interface used to connect to the ISP or to the remote network, and that remote network interface also requires an IP address, and we must give the command no shutdown. So we have now configured the Ethernet interface. The next interface we are going to configure is the serial interface /0/0/0, and then assign the IP address 172.16.0.1. This is the class B IP address, and the subnet mask is 255.255.0.0. And remember, we must give the command no shutdown every time we are configuring this interfaces. So you will find there is only one statement that is coming to show that the interface status is up. But once we configure the remote router, then we will get to see the second message as well. So at this point of time, we have assigned the IP address to the interfaces and then made the status of the interface to up. And now we must tell the Amaravati router how to reach the network of Hyderabad, and this is the different destination network. This is called as destination network. We are providing information to Amaravati router how to reach Hyderabad, and what is the next router's IP address which will guide to reach the destination. And then we have, this is called as static route. This is the configuration called static route. We are manually defining the path from Amaravati to Hyderabad, and we will be doing the similar thing from Hyderabad router to Amaravati router as well. Okay. So the next statement is to configure the static route with the command IP space route 192.168.202.0. This is the network ID. Remember, in one of the earlier sessions of IP address, we discussed about the network ID, the broadcast ID, as well as the valid IP. Valid IP is something we give to a single device, single computer, single printer or server, etc. Whereas network ID is something we represent for the whole organization LAN or the whole organization network. So whenever we create a static route, the static route must be done from the local network to the remote network. So we must have the knowledge or information about the remote network. So we have done the static route on the Amaravati router, and now it's time to configure the Hyderabad router, after which we can check the communication that the local computer in Amaravati will be able to access the remote server in the Hyderabad network, and similarly the local network in Hyderabad should be able to access the remote network server in Amaravati. Okay. So let's look at this configuration: 255.255.255.0, and then the next hop IP address is 172.16.0.2. So this concludes our configuration of the Amaravati router, and then we have to check the communication, before which we will verify the route, show IP route. So we have only one information, that is the local network information. We do not have the information of Hyderabad at this point of time, because we have not configured the Hyderabad router yet. So let's quickly get to configure the Hyderabad router, and as discussed, we have to choose the option called CLI mode, and then we have the option called do you wish to configure the router, yes or no. So we should choose the option no, and then we come to this basic prompt where we give the command enable and then give the command configure space terminal, and then we give the command host name, and then we give the keyword to represent the name of that particular office network router, and then we give the command interface fast Ethernet 0/0, and then assign the IP address to the interface IP address 192.168.202.1, and then the subnet mask 255.255.255.0, and then the command no shutdown. This will activate the interface fast Ethernet 0/0, and then we go to the interface serial 0/0/0, assign the WAN interface IP address 172.16.0.2, and then the class B subnet mask, and then the command no space shutdown. So with this, the basic assignment of the IP addresses to the interfaces is complete, and we have to create a static route from Hyderabad to reach Amaravati network. So let's complete that as well to verify. So the IP address of the Hyderabad network to Amaravati network is 19 IP route 192.168.201.0, followed by the subnet mask and then the next hop IP address. Now with this, if you verify the routing table called show IP route, you could see that there is a static route. So you can see the codes here. The codes here represent the name of, you can see a static, S for static. So we just created a static route from Hyderabad to Amaravati, and then we can see in the output that there was a static route created, and this is the path, this is a route available from Hyderabad to Amaravati network. At the same time, when we come from the output that we have in Amaravati network, there is a different output now. There is a path available from Amaravati to Hyderabad. This is a local area network of Hyderabad network. So now if we go to the computer, this is the computer from which we could check the reachability. So remember, this is the IP address of Amaravati network. So we want to check the reachability to the Hyderabad network 202.192.160.202.10. So you will find that there is communication available from this network to the remote network. You can see here there is a successful communication. In the previous examples, we have seen that ping is a command to check the reachability from source to destination. So now there is reachability. So now let's go to the Hyderabad network and check the communication towards Amaravati network. So there is communication possible, which was not possible earlier because we have enabled the routing in the Hyderabad router as well as Amaravati router. Static route has been defined. You can see the ports are green, which means they are active, and there is a route available from Hyderabad network to Amaravati network as well as from Amaravati network to Hyderabad network. For both sides, we have created the static route and there is communication possible. So let's create a web server here, a quick web server. We need to assign the IP address to this web server as well, 192.168.201.100. This is the IP address of the web server in Amaravati network. We need to provide the default gateway IP address as well, which is a router IP address, and we need to check that there is the IP is configured properly. Go to the command prompt and give the command IP config. So you can see the parameters is assigned. Now we go to the services and then go to HTTP services. In this, there is a message already available. So just to create some message here, we give welcome to Amaravati network. So we created a small message and then we're going to save it, and then we go to the PC in the Hyderabad network, close this window, go to the web server web page. Here we are going to type the IP address of the web server in Amaravati network, 192.168.201.100, and then you can see that there is a message, welcome to Amaravati network. So you can see there was a message arrived from Hyderabad requesting the web page of Amaravati server. So similarly, on the Hyderabad network, we will create similar IP address relating to Hyderabad network, 192.168.202.100, and then the default gateway 192.168.202.1. I'm sorry, this is the DNS server. Yeah, here, correct. So we have assigned the IP address on the server in Hyderabad network. So let's verify IP config. So we have got to see, sorry, yeah, here we have the IP address of the server as well as of the default gateway. So now we go to the services, and in the services we give the command welcome to Hyderabad network. So we've given some message here. So we could see this message available when we access from Amaravati network. We want to access this server. So we go to the PC in the Amaravati network, close this window, go to the web browser. This is the object, web browser object, and then we will type the IP address of the server of Hyderabad, 192.168.202.100. This is the server IP address, and then we can see the web page. So you can see here the message, welcome to Hyderabad network. So this is how we could verify that we have the access from one local area network. So this is a local area network of Amaravati, and we want to access the remote network of Hyderabad, as well as the local network of Hyderabad should be able to access the remote network of Amaravati. So we were able to provide this communication because of the help of the router, as well as the routing protocols that we have enabled on the router. So this requires an important things like establishing the local area network, using the local router, and providing the input of the IP address of the LAN, IP address of the WAN, as well as enabling the routing protocols. So we have seen there were three different methods of routing, that is static routing, dynamic routing, and default routing. So we can use any of these methods which is suitable for the organization. But for small organization networks with few branch offices, we prefer to use the static routing. And this static routing has to be enabled both on the source router as well as on the destination router. So both the routers should have knowledge of the remote network, and that information is manually provided by the administrator. But if the network is big, let's say an ISP, or let's say a bank which has hundreds of branches all over the country, so we will not be able to use the static route. So we have to use dynamic route or dynamic routing protocols for such large networks. So on the internet, we have lots of ISPs across the globe, and these ISPs use dynamic routing protocols. For small organizations, we use static routing. For large organizations and ISPs, we use dynamic routing. So we have seen in today's session how to build a network with two branch offices, and how to assign IP addresses and the default gateway. And we also have seen the important concept of how to configure the router, Cisco router, using this Cisco packet tracer simulator. So you can download this application from netacad.com. It's a free registration, and then you can download it, and then you can set up this on your own PC, on your own laptop. You can run this application and learn how to build or set up networks and enable communication with the help of the router. So today, to summarize, we have learned about the applications, networking services, the client application, the server application, and we also have learned about how to configure the router and verify the communication between the PC and the web server. So we can enable many more such applications like FTP, email. All this also can be enabled in this type of networks. So I hope this session was informative and you will take advantage of this. And in the next session, we will learn about how to actually connect to the internet and what are the other protocols and services required to enable internet. Thank you. Hello, welcome back to the Google IT course. Today we're going to discuss about networking services connecting to internet session 2. In the last session we've learned about how to enable the routing, the different types of routing protocols, and we have actually configured the router so that it can allow the data to go from one network to the remote network. So today we're going to continue those discussions and actually see what are the requirements to connect to internet, what are the components required for accessing internet, also to discuss about the differences between the private IP address and public IP address, and what are the range of private IP addresses and public IP addresses. And we'll also discuss about an important concept called network address translation, because to be able to access internet, the network address translation is mandatory. So let's get into the session by looking at what we have, the contents to learn. And in this page we see that the different types of IP addresses, that is public IP address and private IP address. So the IPv4 addresses are divided into two categories called public IP address and private IP address. These public IP addresses are those which are provided by the Internet Service Provider, ISP. Public IPs are always allocated by the ISP, whereas the private IP addresses are those which are allocated by the local administrator, and these IP addresses are free to be used. But which is the scope of the private IP addresses and which is the scope of public IP addresses? In the earlier session, we have learned about the total range of IP addresses for each class, and we also learned about the class A, the class B and class C type of addresses and their ranges. So from each of this class, certain IP addresses have been reserved and they have been assigned as private IP addresses, and we can see in this page the total set of private IP addresses reserved, and these are the private IP addresses reserved in class A. Only the 10.0.0.0 network is reserved, which means there are about 16 million IP addresses. There are about 16 million private IP addresses in this class A reserved networks, whereas in class B there are about 16 different class B networks reserved, and each of this class B network provides 65,534 IP addresses, and in class C we have 256 class C networks, and each class C networks provides up to 254 IP addresses. It's going to be 254 multiplied by 256 to get the total range of private IP addresses. So these are the addresses that are free to use, and any organization can make use of these IP addresses. And the important rule is that the public IP addresses are those which are other than what is mentioned here in this class A, B and C. They are called as public IP addresses, and private IP addresses we cannot use to access internet. Means when your computer has a private IP addresses, we cannot access internet. So that is the important rule in the IPv4 addresses. If you want to access internet, we must have public IP address. Private IP addresses are free and they are listed here. These are the private IP addresses. Any organization can make use of these private IP addresses. So what are the requirements to access internet or to provide internet? So the following are the requirements to access internet. The first one is we must have an internet connection from the internet service provider in the form of a cable or maybe in the form of a wireless communication. So once we have the physical connection coming from the ISP to our home, to our office, the second requirement is the ISP must provide public IP addresses. So if you look at this example of, consider this is the ISP, internet service provider, and he is providing this cable to our home or office, and we are connecting this to mostly a Wi-Fi router. So a wireless router will be available. This is wireless router, and this is the cable that is provided by the ISP, and we connect this cable exactly on the WAN port of the router. There will be a WAN port on the router, and this is connected, this ISP's cable is connected to this. And then we may have at the home, we may have the laptops or tabs or smartphones. We use various devices. All these are wireless. These are all wireless devices. Through Wi-Fi we want to access internet at home. So this is our home or a small office. This is home or office, and these are the various devices like laptop, PC or smartphone. So these are the devices that we want to connect to internet. So we have seen the components. One is the internet connection, the cable coming from the ISP, and then once connected to the internet, ISP would provide public IP address, and he would provide the public IP address to this particular wireless router on the WAN port. We have seen the router being there, and the fourth one is the users or the devices, network devices which are used by the users will be given a private IP address. So which means these devices will be having the private IP addresses. This will be having the private IP addresses, and the ISP would provide the public IP address here. So all these private users will now have to access internet, but it is contradicting our statement that to have internet access we must have public IP address only. But if you look at the total scope of IPv4 addresses, approximately 4 billion addresses available, but out of these there are some reserved IP addresses which cannot be used. But today the number of devices across the globe which are accessing internet is far more than what is actually available. So there was a process that was designed called network address translation. With the help of network address translation, we can convert the private IP address to the public IP address and then access the internet for all the internal users. So let's look at what we have here. These are the requirements. We have an internet connection, the ISP would allocate the public IP address, and we have a router in our home or office, and then the internal users have private IP addresses. So the next important aspect to know about the public IP addresses, importance of public IP addresses to access internet. Since we are already aware about the range of private IP addresses, other than these private IP addresses, they are all public IP addresses, and they are allocated by this global body called IANA. How are the IP addresses allocated? Internet Assigned Numbers Authority. This is the global body which manages both IP version 4 and IP version 6 IP addresses. This organization will allocate the IP addresses to whom? To Regional Internet Registry. RIR stands for Regional Internet Registry. There are 5 such global bodies. There are 5 such global internet registries depending upon the region. So India falls under the category called Asia Pacific Internet Network Information Center, APNIC. We call this as APNIC. APNIC is the region where India falls under. So under this RIR are the ISPs across these regions. So if you consider BSNL as one ISP, or Airtel or Tata or Reliance, whoever it is, these ISPs have to ask the RIR for the public IP addresses, and this RIR in turn will get IP addresses from the global body called INA, Internet Assigned Numbers Authority, and these ISPs in turn will allocate the IP address to the end users like us or organizations, companies. So they have, where do we get these IP addresses from? From ISP. Where do ISP get the IP address from? Regional Internet Registry. And where do these RIRs get IP from? From the global body called IANA, Internet Assigned Numbers Authority. So that's the concept, and we have to know that only the public IP addresses which are assigned by the ISP are routable or usable on internet. We will not be able to access internet from the private IP address. Even if some user try to access internet with a private IP address, he will not be able to get connected. He will not be able to access the websites because the request will not be processed by the ISPs. So only one IP address will be provided by the ISP to the users, small users, home users, broadband users. Only one public IP address will be assigned to the users. But in the network, in the organization, in the home, there will be multiple users who wants to access internet at the same time. So to provide internet to all the users at the same time, we have to use the concept called Network Address Translation, or NAT. So NAT is very important, and we enable enable this on our router so that users can access internet. So let's discuss about what is NAT, Network Address Translation. It is the process of converting one IP address into another. Translation is converting one IP into another. So here network address actually refers to IP address. Network address means IP address, and translation is converting from one IP to another IP address. So normally there are different types of translation available. There are different methods of translation available, but most times or widely used method is to convert the private IP addresses which are used in the local area network of the various organizations and homes to public IP address. And why should this happen? Because to able to access internet, we must have public IP address only. So the LAN private IP addresses will be converted to public IP addresses assigned by the ISP. And when your request goes out of your network to the internet, when the reply come back, it will come back as public IP address. It will again be converted into local IP address or private IP address. So the process of converting a private IP address into public IP address and public IP address into private IP address is called as NAT, or Network Address Translation. And there are different types of methods of translation available. We are going to discuss about the most widely used among all these, called Port Address Translation. This is the method that we are going to use on our routers and going to configure and verify the output. Port Address Translation. So static NAT is another method used, and this is required or to be used only when an organization has public servers. When the organization has public servers. So what do we mean by public servers? Let's suppose an organization has a website hosted in their network. Let's say we have in our office a web server. Let's say apssidc.gov.in, or maybe yahoo.com or google.com, some website that we are hosting in our network. And users from internet, all over internet, want to access this server which is in our office. So we have to enable the static NAT in our network for allowing the users from internet to access the server in our office. We have to implement static NAT. So hence we say, if an organization has public servers, then we must enable the static NAT. But if you want our local users to access internet, then we must enable this port address translation. Both these are important, but static NAT used only when you have a server in your network. But to access internet, which is common for everybody today to use internet, so PAT is a feature that is available to be configured on the routers. But in the small home office routers which we use, this feature is enabled by default. So normally what we do, we buy this router and then just connect the cable coming from the ISP, and then we start using it. We call this as plug and play. because all the required configurations are already set into this device. But now today we are going to look at how we actually enable this configuration and then test the communication. So if you look at this topology we have today, this is different from yesterday's topology. Yesterday we have used only 2 routers, but today we have 3 routers, and slightly the configuration has been changed, but the local IP address of the PCs remain the same. You can see here, this is the IP address of this computer, the same thing that we used yesterday. IP config will provide the local computers details, and then this computer here also has a private IP address which is from a different series, IP config. So yesterday we have made static routing so that these 2 PCs can communicate with each other. But what's different in today's topology is that this is one organization which is available in Amravati, and this is another organization which is available in Hyderabad, and both these organizations are connected to the ISP. Both these organizations are connected to the ISP. So when you connect to the ISP, as discussed, we will be provided with the public IP addresses. So I'm going to show you some output of the router's configuration, which is slightly different from yesterday's. So the commands that we have learned yesterday, we will use enable to come to the privilege mode, and to verify the configuration, the command is show space running -config. This is the command which will enable us to check the current status of the router's configuration. So this is some part of the output display. There is still some additional information, so you get this more represents there is more information available. So you can either press the enter key to check one line at a time, or you can press the space bar on the keyboard and you can get one full screen at a time. So this is the IP that we allocated to the fast Ethernet interface yesterday, and for serial interface we had a different IP address used, that was 172.16.0.1. So but today you see there is a different IP address because we've changed this to the public IP address. This is the public IP address allocated by the internet service provider. So we have changed the WAN interface IP address to public because allocated by the ISP. In a similar way, on the Hyderabad router also we have changed the WAN interface IP address. The LAN interface IP address remain the same, and the command to verify is show space running -config. This command would display the current status of the interfaces of the router. So we can see here the Ethernet interface IP address as well as the serial interface IP address. So this is the public IP address and this is the private IP address, because in the LAN we have a lot of computers and servers. Okay. So now with this we want to communicate from the Amravati computer to the router, public IP address of the router. So this is the IP address we want to communicate from this PC. So we go to this PC and ping with the IP address ping space 202.2.0.18. So we want to communicate with the router. So you get a message called destination host unreachable. Destination host unreachable. This is an error message, and we get this message from the device IP, which is our router. This is the IP address of the router. So remember, this is the IP address which is replying to us that there is no route or path to the destination. Destination host unreachable. This is being displayed from the router, which means our router do not have the path, the local router do not have the path to send the message to Hyderabad or from Hyderabad to Amravati. So to be able to perform that, we have to enable something called as routing. We have to enable the routing. So port address translation is a method which converts many private IP addresses which are in the local network into one public IP address. Translation from many private IP addresses into one single public IP address. and this public IP address are provided by the ISP. He will give only one public IP address, and in our network we have multiple users, and all these private IPs are converted into one single public IP address. So with PAT enabled on the router, all users can access the internet at the same time. So on the home broadband routers or the Wi-Fi routers, this PAT feature is enabled by default. We don't have to do any additional configuration. So just PAT does not suffice. We need to enable a default route. Remember when we discussed about the types of routing in the previous session, we have discussed about static route, dynamic route and default route. So we have to enable the default route on the router. So the command that is required to enable the default route is mentioned here. In the configuration mode, we have to give this command IP space route followed by 0.0.0.0, where this represents any destination. You want to access any destination, it represents 0.0.0.0, any destination. And this next zeros represents any subnet mask, and then the next exit interface. So we are now going to enable that specific default route on these Amravati router as well as Hyderabad router. Whenever you connect to internet, you must enable the default route towards the ISP on all the routers connecting towards internet service provider. So we log into this router, go to the configuration mode, configure terminal, and then give the command IP space route 0.0.0.0. On all the 4 octets, the value will be 0, means any destination, because on internet we have millions of destinations. On the internet you want to access, there are hundreds of thousands of destinations. We cannot keep a route available for each and every destination or for each and every website. So whenever a router is connected to internet, we must enable the default route, and the default route goes as IP route 0.0.0.0, means any destination, followed by 0.0.0, which is any subnet mask, and then we have to specify the exit interface through which interface the router is connected to the ISP. So we have 0.0.0.0 followed by the exit interface, which is serial 0/0/0. So with this static default route created on the router, we need to verify the routing table whether this particular route got established in the routing table of the router. This has to be established in the routing table, and verification of the routing table with the command show IP route. So you can see here in this output there is one special entry called S star. S star represents static default route, which means now if any route is not available in the routing table, the router will forward the packet to this particular destination via this particular path. But if we check currently in Hyderabad router, we do not have that entry. On the Hyderabad router, if we check the output of show IP route command, you won't have that default route because we have not yet enabled. We have not yet enabled the default route on that route. There is no static route, default route here. So the command to enable the default route is IP route 0.0.0.0, which is any destination, and 0.0.0.0 any subnet mask via serial 0/0/0. Whatever is the interface, it may be different in your case. So now we have the option available. So we have the default route available on both Hyderabad router as well as Amravati router. And now if you try to ping from the local PC here, if you try to ping to the remote public IP address, ping 202.2.0.18, you won't get response still, but you won't get the message destination host unreachable. You will get request timed out. So the message is different. Now after creating the default route on the Amravati router as well as Hyderabad router, the local PC is sending the packet to the router, and the router has a default route available towards ISP. But local PC has private IP address. But from private IP address we cannot access the public IP address. So we need to enable this concept called PAT. Port address translation has to be configured on both Amravati router as well as Hyderabad router. Then we will be able to communicate from the local private network to the public network. So let's look at the configuration commands to enable the PAT, port address translation. So we have to now get into the router, Amravati router first, and then configure terminal, interface, the ones which we have used, fast Ethernet 0/0, IP NAT inside, representing that this is a local LAN interface. Then interface serial 0/0/0, which is a WAN interface, IP NAT outside, representing that this is the interface connecting towards the ISP. And then we have to create an access list. Access list, you can give any number between 1 to 99, and then permit space the local network 192.168.201.0, and then there is a wildcard mask 0.0.0.255, and then give the command IP NAT inside source list. We have created an access list with number 12, so that number has to be substituted here. Access list 12, then interface, the interface which is provided by the ISP, which is connecting to the interface access list number 12, then interface serial 0/0/0. This is the interface which is connecting towards ISP, and then the keyword called overload. So with this, the PAT configuration on Amravati router is complete. But if you verify the output of the command show IP route, you still have the default route which is required for internet access. And now I am going to establish communication from the local PC here in Amravati, because the Amravati router's PAT configuration is complete. So now we have to check the communication. So I am going to ping to the same public IP address, and then I just use the up arrow key from the command prompt, and now you can see there is communication. So which means this computer, this particular computer is saying that I want to reach the public IP address of the Hyderabad network, and the request is coming all the way from the PC to the switch. Switch is forwarding to the router. On the router, this particular private IP address has been replaced with the public IP address assigned by the ISP. So this process of converting private IP address to public IP address is called as PAT, port address translation. So now if we go back to the router to verify the output of the command show IP NAT translation, this is the command to verify the output. So you can see there is a long output here. So let's see how we read this. So in this output we have protocol, means what type of protocol is used for communication. Ping and traceroute commands use ICMP protocol. ICMP protocol, Internet Control Message Protocol. If you use any web traffic or FTP traffic, then it will use TCP protocol. Then we have inside global. The inside global represents the public IP address assigned by the ISP to the customer, to the user. Then this port number, this is the port number. We have mentioned earlier, for website it is port number 80, for FTP it is port number 21, for DNS it is port number 53. So these are the port numbers reserved for the services or network services or applications. The next column is the inside local, which represents the private IP address of the local computer generating the request. Then outside local and outside global, both these represent the remote destination. This is the remote computer router IP address which we are trying to send data. Okay, so this is how we are able to access the internet with a private IP address. The router is converting your local private IP address into public IP address with the help of network address translation method called PAT, because NAT has different types like static NAT, dynamic NAT, PAT, port redirection NAT. So multiple types of NAT is available. So the method that we have enabled on the local router is PAT, port address translation. But we now go back to the Hyderabad router PC and then try to ping to this public IP address of Amaravati network. So the command is ping followed by the public IP address 192.1.0.17. This is the public IP address of Amaravati router. So you get a message request timed out. Because the default route is available, you get a message called request timed out. You are not able to get the output. So now we have to enable the port address translation on the Hyderabad router. So the commands to configure on the Hyderabad router: configure terminal, then interface fast Ethernet 0/0. Because this is a LAN interface, the command is IPNAT inside and interface serial 0/0/0, the interface connecting towards the ISP. Then the command IP NAT outside, and then create an access list. Access list number can be any number between 1 to 99, and then permit the local network of Hyderabad, which is 192.168.202.0 and 0.0.0.255 is basically the wildcard mask, which is opposite of subnet mask or inverse of subnet mask. And then IP NAT inside source list followed by the access list number we have used here. So the same number has to be defined, and then interface serial port number is 0/0/0, and then overload. With this command we will be able to allow internet access. So now we come back to this computer from where we did not get the output to access the Hyderabad to Amaravati public IP address. So you see, now you get a response. So this is how the PAT helps the local users of an organization or a home which have a lot of private IP addresses to access internet. So you can confirm from the router with the command show IP NAT translation. So you can see here the local IP address of the PC is 192.168.202.10, and he is able to translate, the router is able to translate his public IP address to the private IP address to the public IP address, and then reach the remote network. Okay. So just as a example, let me take you to my computer, my local PC. I am not using the simulator now. This is my laptop, and I check IP config, which is providing me the current IP addresses on my computer, and I am using the keyword more. More means it will show one screen at a time. So on my Wi-Fi interface, you can see there is a private IP address. See the IP address that's mentioned here, 192.168.43.35, and then the default gateway is 192.168.43.1. So this is the parameters that I have on my computer, but this is a private IP address. This is a private IP address. So with this private IP address, I should not get internet. But you observe here, I said ping zoomgroup.com and I get the response. So what's happening here, my request is forwarded from my computer, which has a private IP address, to the default gateway, which is the router, and the router is converting this private IP address into the corresponding public IP address. So just to show you, if you have to find out, you are having access to internet in your home. Now we want to check what IP address was allocated to your computer. So there is a website called www.whatismyip.com. This is a website which provides the actual public IP address allocated to you, your organization, to your router from the ISP. So you can see here the first line, your public IP address is mentioned here, 27.59.199.226. and this whatismyip.com is a website which is providing this service, and you can see what public IP address was assigned to you by your ISP. In fact, it will also display information about your local IP address. You see, my computer IP address also has been displayed, 192.168.43.35. we have seen here in the previous page. This was the IP address allocated to the computer, to the laptop, by the local router, and this is the public IP address assigned by the ISP towards the router. And it's also mentioned who the ISP is. The name of the ISP also will be displayed in this screen. So it is a very useful website, whatismyip.com. There's no space, it's one word, whatismyip.com, and you can see the public IP address allocated to your router and your computer's IP address and the name of the ISP, the location, all these details. Okay. So finally, what we have learned today in the session is about IP address, the difference between the private IP address, the location, and the public IP address, all these details, the importance of public IP address. So finally, to access internet, we must have learned today public IP. The session is about within the LAN, within the organization, private IP address, one computer to another computer, public IP address, or from the computer. The importance of public IP. We just require to private internet. We must have learned today public IP. Who allocates this public IP address within the LAN, within the organization, private IP address, public IP address, or from the computer. The importance of public IP. These ISPs get public IP address from the regional internet. Who allocates this public IP address within the LAN, within the global body called public internet assigned numbers of public IP. But just having the public IP address alone is not enough for the whole network. One single IP is allocated to the router, but within the network we have multiple computers. They all have private IP. But just having the public private IP, we cannot access it for the whole network. On the router, we have to enable a feature called PAT, port address translation. They all have private IP of the port address translation. So with the private IP translates or converts the private IP address into public IP address. So in this session, in the previous session, we learned about the various concepts relating to private IP internet to access internet connection, what are the prerequisites, what features have to be enabled, including the default route. Just configuring the path, not having the default route, we will not be able to access internet connection. Router prerequisites, ISP needs a public IP address to the router, including the default route, then we have to enable the path. So with this, we will be able to access connection router, and all the small home broadband router features are enabled by default route. Only when you write professional router, when using a large organization, we must enable this configuration. All the small home broadband router, I hope this is enabled by default route. It will help you in getting greater knowledge configuring the router for this configuration. All the small home broadband router, I hope this is enabled by default route. It will help you in getting greater knowledge configuring the router for this configuration. All the small home broadband router, I hope this is enabled by default Hello, welcome back to the session. Today we are going to discuss about the troubleshooting and the future of Internet session 1. Hello. All the last few sessions we've learned about What is networking?
We're going to discuss about
What are the types of networking, components required to set up the network, how these devices work, what are the various protocols available for communication,
types of
how to use those protocols, and we have practically demonstrated how these devices an aspect of how what are the various protocols available for communication, the remote network, with the help of the switch and the router, and the various protocols that we have to enable on the router. We also taken examples of how to access internet by configuring the router. So what happens if something does not work on the router? There is some situations where the computer may not be able to access internet, it may not be able to access the local server, it may not be able to send a print if something does not work. Local printer, we are not able to get some access. So how are we able to troubleshoot this? We are not able to access the local server. We cannot say network will work correct all the time. Local regulation, we are not able to solve problems. So what are those problems and what are the different types of problems available? We cannot say how to resolve them or how to address these problems to ensure that your network is running all the time without any issue. So troubleshooting is a very important aspect of network. So let's look at what is troubleshooting and the different methods of troubleshooting. So troubleshooting is a very important aspect a method of resolving the network. Let's look at troubleshooting and the method of resolving the various network issues or problems. So it is a method. So sometimes we may try to access some resources, some web server or something. We don't get the required output. That means there is a problem. So the troubleshooting is a method of first identifying the problem. What is the problem? Why is it not working? Why am I not getting the web page? All these are the issues that we identifying the problem. Identifying the problem is the first step in troubleshooting. Why am I not getting the web page? Let's take an example of ourselves. Suppose we are not well. Where do we go? We go to the doctor. We go to the doctor when we have some problem or we have some issue. Similarly, in the network, when something does not work, then the network engineer or system administrator has to address this problem. So the first and foremost thing that when we go to the doctor is what's the problem, and then we explain the problem that we have. And the doctor will diagnose, okay, this is the problem, so this is the medicine to be provided. In a similar way, when something does not work in the network, in an organization network, in a bank, or in any organization, ISP, a problem, so if something doesn't work, the technical person, network engineer, will look at why this problem is. We have to identify what is the cause of the problem. We call it a root cause analysis. In the root cause analysis, you will find out what is why this issue, what is the problem, why is it behaving like this, cause of the problem. And then there will be a stepwise process that we have to follow to address this. What is why this issue, what is the problem. So this what is the solution. So if there is a problem, there is a corresponding solution. Troubleshooting is the process of resolving the problems that we have in life. So this so let's get back to the problem. What are there is a corresponding solution. So once we are able to identify the problem, then we have the solution based on the problem. We have a different type of solution. Once we are able to identify what are the different types of problems, then we have problems that are related with layer 1. We call layer 1 as physical layer 1. What are the different types of layer 1 problems? So these are related with physical connection. Layer 1. Maybe the cable is not connected properly, not fixed to the interface of the computer, to the laptop properly, or maybe the cable is disconnected or damaged. The cable could be damaged properly. So these are the various issues relating to layer 1 laptop properly. According to the OSI model, that the layer 1, layer 2 and layer 3 are the three important layers relating to network. So in that layer 1 is physical layer. The layer 1 we have to address this physical layer could be relating with cable disconnection or cable being damaged or cable not being connected properly. These could be the issues for address this physical layer could be relating with what kind of problem that exists in layer 2 or cable not being layer 2. Problems could be related to encapsulation, and normally this happens on the WAN interface. WAN encapsulation could be one issue. Within the LAN, there could be issues of speed and duplicate. Normally, these layer 2 problems can be categorized as relating to encapsulation mismatch or relating to speed and duplicate. This is the layer 2 problem. Troubleshooting using the layer 3 issue, layer 3 problem or relating to layer 3 is related with network layer. Layer 3 is related with the network using the layer 1 is the physical layer, layer 2 is the data link layer, layer 3 is the network layer. So in the network layer we have components like IP address, layer 1 is the physical layer, IP address related with layer 3. So IP address issue could be routing protocol issues, or it could be kind of providing a wrong IP address as a default gateway, because in the TCP/IP properties we have IP address or it could be subnet mask providing a default IP address, and apart from this we also have DNS server. So if any of these parameters are not correctly provided, if any of these parameters are not correctly provided, be it IP address, subnet mask, default gateway, DNS server, or the routing protocols that we have enabled on the router. If any one of this is an issue, then the user will not be able to access the internet, or the user will not be able to access the routing protocols that we have enabled on the router. The parameters that we have to troubleshoot for layer 3 connectivity or layer 3 troubleshooting is IP address, subnet mask, default gateway, DNS at the computer level. If all these parameters are correct and still we don't get access to the remote network or internet, then we have to troubleshoot on the router. On the router, again we have to troubleshoot relating to the routing. Still we don't get some of these routing protocols we have done in the last few sessions, relating to static routing, relating to default routing. So we need to check those parameters. We will be using some of these concepts in our topology that we discussed in the last few sessions, and then create some problems. We will remove some information relating to the IP parameters. We will remove the default gateway. We will give wrong subnet mask and then try to access. We will not be able to information. And then we have the last one. And then configuring the routing protocol, it could be you could have given a wrong routing information to the protocol. These are the various problems for layer 1, it could be, and then layer 2, and then layer routing. So we're now going to look at the solution, how to solve these issues. Various solutions relating to addressing these problems. So troubleshooting layer 1. So we need to check the physical connection to the PC. The LAN cable, is it connected properly? Most computers or laptops have the facility to show that the light is on. When you have the connection, the cable connected to the computer, the light will be on. So if you see that light, that means there is a connection. Behind the computer or laptop, when we connect the LAN cable, on that port there will be light, LED. And if it is glowing green, represents the physical connectivity. In spite of connecting the cable and we don't get the light on that port, there will be light, LED. There is a problem with the jack, there is a problem with the cable, or the remote end of the cable which is connected to the switch or to the hub has not been connected properly. Another situation could be like the switch is powered off. These are things that we have to look at. Not physical connection connected properly. And sometimes on the router, the physical cable is connected, but the router port is shut down. So we need to verify that particular configuration on the router. And then we also have to look at the physical cable is connected, PC, but cable and the switch and the router. These are the three things that we have to verify for the physical layers communication or layer 1 communication. So once this is resolved, that means the light is on the computer side, that means physical connection is active. To resolve the layer 1 issue. And then layer 2 issues can be resolved by checking the status of the interfaces on the router. And we mentioned earlier the problem in layer 2 would be relating to encapsulation. Normally we map this encapsulation for the WAN interface of the router, not for the LAN interface. Whereas on the LAN interface of the router, the status of the interface should be checked on the switch and as well on the router. So what parameters do we look at for the layer 2 encapsulation is duplex and speed parameters. If these are matching the devices connected, then the layer 2 status also will be encapsulation. The problem of layer 2 will be resolved if we address the encapsulation on the WAN interface and speed and duplex on the LAN interface. The layer 2 status also will be resolve the issues of the layer 2. So once this is resolved, so we have checked layer 1 troubleshooting and rectified those problems, then verified layer 2 issues and rectified those problems. And the third one is the layer 3. So layer 3 is relating to the IP parameters, the default gateway, DNS, as well as the routing. But if you look at a topology that we have discussed earlier, allowing the data from one network to go to the remote network, at every stage there are certain things to be checked. But if you look at every stage of the communication, we have to check certain parameters. So when the computer, which the user is using, initiates a request, at that computer itself, the information relating to layer 1, which is the physical connectivity, or maybe wireless connectivity. Number 2, relating to the MAC address, source MAC address and destination MAC address, and relating to layer 3, which is IP parameters. So all these will be checked right from the source. Number 2, and then the request will be forwarded from the PC to the switch, and relating to layer, the switch maintains the MAC address table. It will verify to which port this parameter has to be forwarded. The request will be forwarded from the PC, and it will look up in its MAC address table where the router is available, and then this packet will be forwarded to the router. When the router receives the packet, the router is a layer 3 device, and it will look up, open the IP table and check the destination IP address, and the packet destination IP address will be compared in the router routing table. Router maintains routing, switch maintains MAC address. So when the routing table is checked for the particular destination, if the destination is available, then the packet will be forwarded out on the exit. So when the routing table, we have to understand this. Let's take a small picture. If the destination is available, then the packet in this picture we're going to create a small network. We have to understand this. Let's take a small router. If the destination is available, and then we have in this picture we're going to create a small network, a switch connected here. We have to understand this. To the router. If the destination is available, and then we have in this picture some devices, a small network, a switch, some PCs connected to the switch, to the router. At least one or two computers we can consider. In this picture, some devices, and then the PCs are connected to the switch, to the router. At least one or two computers. And then this router is in turn connected to the remote router, and then the PCs are connected to the switch, to the router. At least one or two computers. And then this router is in turn connected to the remote router. In this remote router also we have a switch and two computers connected. And then this router is in turn connected to the remote router. In this remote router, and we wish to communicate from the local network to the remote connected. So if you look at, if this PC is sending data out to the router, and we wish to communicate from the local network to the data out. So if you look at, this PC is sending data out to the router, and we wish to communicate from the local network to the data out. So if you look at, this computer is a source, sending the data out, and this computer is a destination computer, sending the data So this network would be different, this network would be different. So when the packet is sent from the PC towards the switch will check in its MAC address table how to forward this packet to the router. And the packet will be forwarded based on the MAC address table, and the router will verify in its routing table how to forward this packet to the router, on which interface the destination is reached. So currently there is only one port available to go to the remote network. The packet gets forwarded, IP packet gets forwarded on which the router, and then forward this packet from the router to the switch, and then from switch to the forwarded. So in this process, if there is a fault in the switch or if there is a fault in the router, any of these segments, the source cannot communicate with the destination. So in this process, we have, if there is a fault in this diagram yesterday, in the last session, we have discussed about how to enable communicate with the. So we were able to communicate from this local PC to the remote router. We were able to communicate along with the public. How to enable communicate with the. So we were able to, there is communication from this local PC. And if you do a trace route, remote router, we were able to do a trace route, it will show the hop by hop communication. There is communication. It will show the hop by hop communication. How the packet is traveling from the source to the destination. So this is the first hop. For the local computer, the first hop is basically the default gateway, which is a router. We can even check from the source our IP parameters on this computer. So this is the first IP for the local computer. The first hop is basically the default gateway, which is the default gateway on this computer shows 192.168.201.IP. And when we try to trace route to the remote device, you can see on this computer shows that the first hop is going to the default 201.IP, and then it's going to the next hop, which is the ISP route, and then the next hop is going to the actual destination. So this is the communication, because all the parameters are correct. So what we do now, we will just go here to the IP parameters and remove the default data. So this is the communication, remove the default parameters are correct. So if you check the IP config now, the computer does not have the default data. And now if you try to communicate with the remote computer, so if you check, you get a message that request time box. Default. You get a message request. And now if you try to, sometimes it's possible that the IP parameters may be disturbed either intentionally or through DHCP server. If you assign the DHCP to this local computer, it's possible that the IP parameters may be disturbed, and the DHCP server does not provide the correct details, correct IP parameters, then also communication is not possible. This is one way we have identified the fault. And the DHCP server does not. And you can go to this computer properties and then assign DHCP. If you assign DHCP, and then we come back to the command prompt and check the current IP address of the PC with the command IP config. If you assign DHCP, and then we come back to the command prompt and check the current IP address of the, you can see you've got a different IP. Command IP 169.254.85.130. Normally when your computer is not able to reach the DHCP server, automatically the computer will allocate an IP address in the series called 169.254. This IP is also coming under the private IP address category. Then you will not be able to communicate with your remote in the series called 169.254. There is no communication IP is also coming under the private IP address category. Then troubleshoot to communicate with your, whenever a user complains in the network that he is not accessing the server, he is not accessing the internet, we need to check these properties. TCP/IP property, whether the IP address is being configured properly, the subnet mask is configured properly, the default gateway is configured properly, the DNS, suppose if you want to access internet property, without DNS we cannot access internet configured properly, because internet works based on IP address configured properly. The DNS works on IP address, not on the domain name. Though we tend to remember the domain name, because remembering the name is easier compared to remembering the IP address. If you access internet, you must remember the IP address, and you cannot. So we are good at remembering the name. easier compared to suppose we want to communicate with, let's say, yahoo.com or google.com. We don't know the IP address of that particular web server. We are good at remembering the name. We know the name. Suppose we want the DNS provides resolution between the name and the. We don't know the IP address of that. Let's quickly have an example of. Good at remembering the name. We know the name. So I want to communicate with yahoo.com. Let's say ping www.yahoo.com. Have an example of. So we remember the name. So I want to communicate with yahoo.com. Let's say ping www.yahoo.com. There is no internet access. So remember the name. Get resolved. I want to communicate based on the domain name. Yahoo. And the domain name service. So remember the name. IP2 name resolution, name to IP resolution based on the domain name. So if the DNS is not configured properly or is wrongly configured, we will not be able to access internet. So DNS is one of the issues that we have to resolve. Remember the name. IP2 name resolution, name to IP resolution, IP parameters are key components, and checking the communication. So if the DNS is not configured properly or is wrongly able to reach the default gateway or internet. One troubleshooting we have to perform. So DNS is one of the. Are we able to communicate with the DNS server or not? And sometimes it's possible two or more devices may have the same IP address, and you will find sometimes the conflict, IP conflict. Checking the communication, the DNS is not configured properly or is not able to reach the default gateway. So how do we resolve this duplicate? DNS is one of the. Are we able to communicate with the DNS server or not? Currently, we have enabled DHCP. And sometimes it's possible close or more devices may have the same IP address, and then assign the static IP address to this computer. The communication DNS is not configured properly or is not able to reach the 1.10. So how do we resolve this duplicate? DNS is one of the. Are we able to communicate with the DNS server default gateway at this point of time? And sometimes it's possible. Check the IP address of the PC. Or more devices may have the same IP address, and then assign static IP address to 192.168.192. And now we can ping to the router. The router IP address is 192.168.201. Are we able to communicate with the DNS server default gateway at this point of time? Suppose, just to create a problem in the network, we are assigning the second computer also with the same IP address 192.168.201.10. The second computer also we are using there, and now we can ping to the router. So you can see a message pop up here that this address is already used in the network. So this is IP conflict. So this being a simulator, it is not allowing you to use this IP address. We are assigning, but in a real network you can assign computer and you get a message that same IP has occurred. So we need to manually define a different unique IP address in the we give the IP address of 192.168.201. You can see a message. Now this computer will accept this IP address. Address is already used in the network. Check. So this is the IP config. So this being a simulator, it is not allowing you to use this IP address. We are assigning, but in a real network, the first computer had an IP address of a message that same IP has 1.10. The second computer has. So we need to manually. So we should be able to ping to the default gateway, which is the router. Now both the computers are able to reach up to the router. Now this computer will accept this. And then you can also ping to the neighbor computer, ping 192.168.201.10. This belongs to the first computer. The first and second computer are able to communicate with each other. And now, to check from the second computer, we are able to reach the remote network. We should be able to ping to the default gateway. We have the router to check the reachability with the command ping. Both the computers are able to reach up to the 202.2.0. Ping to the neighbor computer. This is the IP address of the Hyderabad router. Public IP address of Hyderabad router. This belongs to the first computer. Fine. Second computer are able to communicate with each other. And now, to check from the second computer, we are able to reach the remote network to go up to the router, but it is not taking you beyond the router. Whereas from this computer, we were able to ping to this public IP. 202.2.0.